Hello everybody, welcome to today's class. Today we have this math challenge before us here. The question reads, solve m plus m equal to m times n. What is the value of m that will satisfy this equation? Very easy, right? So let's take our selection here. We have selection. Now in solving this math challenge, here we're going to use two different methods. The first method will give only one of the roots, but the second method will give us three roots. And so endeavor to watch the first method and also the second method to get the difference between these two methods and why one of them will give just one root, the other gives three roots. So if you know that this is my prowess, and if you've not subscribed, subscribe. And when you subscribe, turn on the notification bell so that you get notified whenever we release a good video like this one you're about to watch right now. So we take our solution, and here we're taking the first method. So let's take here first method. All right. So in the first method, now let's go straight by adding these together because they are same variable. So this is going to give us here our 3m equal to, we can equally multiply this together to give us our m to the power of 3. So from here, you discover that we have to solve for three roots, right? Good. But here, let's use the first method. Like I said, will give us just one of the roots. Now from here, what we want to do here is to ln both side of the equation. So if we ln both side of the equation, and again, we can rearrange this. So this is going to give us here our ln of our m to the power of 3. Let's put this in brackets, equal to the ln of our 3m, close bracket. Okay, here we're going to apply about two laws of logarithm. The first one, which says that if you have the log of, let's say, a to the power of x, say move this to this side of the equation. So this is going to give us our x log our a here. Okay, so this is the first law we're going to apply, and we apply this law to this side of the equation, which is this very guy here. Then on this side, this is multiplication. You can put a dot there. So here, the multiplication law says that if you have log your m, then times your n, this is equal to your log your m, there plus log your n. So this one, we're going to apply this for this. So apply the two laws of logarithm. We're going to have this first one to be our 3, the ln of our m, the bracket. This is equal to, then here we're going to have ln of our 3, then plus the ln of our m, bracket. Okay, so here we have ln of m here, we have ln of n here. So we can send this to this side and this remain on this other side. So we're going to have this to be our 3 ln, that's our m, that close bracket, and minus ln of our m, close bracket, equal to ln of our 3. Easy. I believe there's no confusion here, right? Good. So what we do next here now, we can do our simple subtraction here, right? So if we subtract this from this, we are left with 2 ln of m, bracket, equal to ln of 3. Those are brackets. Divide both sides by 2. So we have here, divide by 2, we divide this by 2. This leave the system. So we now have our ln of m, close bracket, then equal to, this expression could be written as 1 all over 2 into ln of our 3, close bracket, right? Good. Now remember the law we just looked at, which is the power law of logarithm. So we can now move this to the side of the equation. So rewriting this equation, we're going to have ln of our m equal to our ln of bracket 3 all to the power of 1 all over 2. Any confusion? No. Look at our m here. We are having the natural log of this. So we're going to introduce e to the system, and it's going to be to both sides of the equation. So we're going to have this to be our e or to the power of ln of bracket m, close bracket, equal to our e also here, to the power of ln of our 3 or to the power of 1 all over 2. We know that this to this will leave because this is ln this e. So this will leave, this will also leave. So we are now left with our m is equal to, we're going to have 3 to the power of 1 all over 2. So we have our m to be this answer here. Okay, so therefore our m is equals to the square root of 3, right? Good. So like I said, we only have one root from this method, just one root using this first method to solve this. Now let's look at the second method where we're going to have 3 roots. So let's take here second method. Second method. So let's put down our question. Look at our question again. We write the question down here. So here we have our m plus our m plus our m equal to our m times our m times our m. Again, if we add this will give us our 3m equal to m to the power of 3. Good. So what we do here, we just move this to the side of the equation and just rearrange. So this will now give us our m to the power of 3, okay, then minus here our 3m equal to 0. Okay, now we are having m to the power of 3 and 3m here. So with this power, we know that we are to solve for 3 roots. And that's why at this stage here, you cannot divide both sides by m. If you do that, you come up with only 2 roots, which is not going to be healthy for this equation. And so we factor out our m from this expression here. So we're going to have here m bracket. Our if we use m to divide this, then we're going to have m to the power of 2. Then m into this will give us our 3, everything equal to 0. From here, we are having this times this equals to this. So automatically, we apply the 0 product rule. We say that we are going to equate this to 0, equate this to 0. Okay? So this is going to give us here m is equal to 0, or our m to the power of 2 minus 3 equal to 0. Okay, so from here, it is easy now. Then we're going to have our m1 is automatically 0. So we've gotten the first value for our m here now. At the end, we're going to do a test draw to check the roots to know if they are actually correct, if they satisfy the original equation. Okay, so we take our case 2. So look at our case 2 here. Our case 2 is our m to the power of 2 minus 3 equal to 0. All we just need to do is to send this to the side of the equation. So we now have m to the power of 2 is equal to positive 3. This is m to the power of 2. So we have to eliminate this power here by taking the square of both sides. So let's take the square root rather. The square root of this is equal to the square root of 3. And immediately we do this, then we introduce our plus minus to the system. So this will go with this. So our m is now standing alone. Is equals to plus minus the square root of 3. So here we have 2 roots from here. And this will give us our m2 is equal to a positive root 3. And our m3, this will give us negative root 3. Easy. Okay, so yeah, we just want to do a simple check if the 3 roots actually satisfy the original equation. Again, in our first method, we only got this answer, which is what we have here, right? So this expression is the same thing as the square root of 3. Okay, so we want to check these 3 roots, this m1, the m2, and m3, if they will actually satisfy the original equation. So let's take our check. So the original equation, we all know that is m plus our m plus our m equal to our m times our m times our m. So when m is equal to 0, what will be the fate of this? So this is going to give us 0 plus 0 plus 0 equal to 0 times 0 times 0. Okay, let's use our multiplication sign here. So this is going to give us 0 equal to 0. So it shows that the first root, which is 0, satisfies the original equation, right? So let's look at the second root, which is x. So second root, we say here when m is equal to our the square root of 3. So what we do is substitute this into this original equation again. So this is going to give us the square root of 3 plus the square root of 3 plus the square root of 3 equal to the square root of 3 times the square root of 3 times the square root of 3. Good. So if we add up everything here, this will give us 3 into the square root of 3 equal to, now root 3 times root 3 will give us root 9. And 9 is a perfect square. So root 9 will give us 3. So we're going to end up having 3. And we still have root 3 here. So into root 3. So this shows that, again, the second root here satisfy the original equation. So we check for the last one. We say when our m is equal to the negative root 3. So we do another simple substitution again from here. So this is going to give us here minus root 3 plus bracket minus root 3 close bracket plus bracket minus root 3 close bracket equal to, here we're going to have minus root 3 times minus root 3 times minus root 3. Okay, so let's look carefully here. Here we are having minus root 3 minus root 3 minus root 3. So if we use this plus to times this minus to give us minus, we use this to times this minus to give us minus. So end up having minus root 3, then minus root 3 minus root 3, everything equal to, yeah. Now minus root 3 times minus root 3, this will give us plus root 9. Now plus times minus will give us minus. Now root 9, like we said before, is 3. So we have minus 3, the remaining bits into root 3. Now this other side, we are having 3 of this. So this will give us minus 3 root 3. So let's continue on this side and see what this gives us. So this is going to give us here minus 3 root 3 equal to minus 3 root 3. So this also shows that the third root satisfies the original equation. Okay, so this brings us to the end of this class. If you have learned something from this video tutorial, give the video a thumbs up. If you have any question with regard to the approach applied here, then drop it in the comment section. Again, if you've not subscribed, do it to subscribe, because at MathProS we bring out videos every day for your learning. Thanks for watching MathProS. Bye.